Welcome, welcome. Today we're going to be looking at point slope second day. So write an equation of line for the warm-up of in point slope using the -2, +3, 4, -1. So you have the equation, you have the various different ways to go through it, and you also have point slope up here. So let's go and get started. So we're going to go ahead and use the stacking method today. So we're going to ask ourselves how we get from -2 to 4, how we get from 3 to -1. So from -2 to 4, notice we're adding 6. From 3 to -1, we are subtracting 4. Alright, so we're just going to stack the 2 and then reduce. So we have this -2/3 for our slope. So we're going to plug in the -2/3 along with 1 point. Notice we used the first point. -2 became +2, +3 became -3. Good to go. Alright. So point slope form, day 2, and graphing. We're actually going to spend another day in this as a touch-up because of the whole rally schedule stuff like that. So we're going to spend one more day in here before we move on. Alright, let's continue. So we had the warm-up. We're going to go to vocabulary, review the vocabulary, go to discussion, classwork, and conclusion. So again, it should be review vocabulary as its slope-intercept form, the previous form we were working with, and the new vocab is still that point slope. So just let's try and get more used to that. So graphing made easy. So we're going to graph the line that has a slope of -3/2. It passes through the point -1, 3. So writing in point slope might be a good idea. We have the slope. So let's bring that in right on in. Now we have the points. -1 goes to the x1, 3 goes to the y1. And remember, you see this double negative right over here, so it kind of needs to go positive. Alright, so now we should try to graph this. So let's look at the fact that we're looking at -1 and x. So we're going to find -1 on x by sliding that arrow just slightly over. Now we're going to find 3 and y. So we're going to slide that up to 3. Where they intersect is where we want to draw our point. So remember, rise over run, so we're going to drop by 3. Then we're going to increase by 2. And draw that line right on in. Notice we do not need our b-intercept in this case. So all we need to do is just write the equation line, and we're done. So you see that where y-intercept would be about 1.5. Do we really want to write that, or would this be more user-friendly? So you can see that it might be beneficial to use point slope at times. And we shouldn't always just default to slope-intercept. Okay, let's have a look at a second example. So we're going to write the equation of the line that has a slope of 10 that passes through 6, 8. So slope of 10, 6, 8. Let's just put that slope in first. So it stays the same, does not change to negative. It's the only right here, the y1 and the x1 that change signs. So that 6, 8 should turn negative. -6, -8. So now that we have our slope in a sense, the reason I put it over 1 is just as a reminder, whenever we have a solid number, we really have it as over 1 to help with our slope case. So we want to find 6, now we want to find 8. And where they intersect is where we go. Notice there's a problem with trying to go forward with this. If we try to go forward and go up, we're off and away and it's no longer on. So instead, we want to drop by 10 and drop by 1. It's just going the opposite direction. So drop by 10 and decrease by 1 on the x. And here's our line. And as you see, this one doesn't even have a slope intercept form on this graph. It's way down yonder somewhere. Could you figure it out? Of course. You would have to say, take this and convert it over into slope intercept. So you could take this and just simply add 8 to both sides, distribute the 10, and then simplify default solve for your b. So there is a way to do that, and we're going to cover a little bit more on that a little bit later. All right. So slightly different. So we're going to write the equation of the line that passes in slope form that passes through 2, 3, and 1, negative 2. So we're going to go ahead and graph these two things first. So 2, 3, where they intersect is our point. 1, negative 2, where they intersect is our other point. So we can just draw that line like that. You can see it looks to be around 7, might be our intercept, but we can probably just go ahead and quickly find where our slope is. Going from 2 to 1, we're decreasing by 1. From 3 to negative 2, we're decreasing by negative 5. So if we just stack those, we're going to get m is 5. So from 2, drop by 5, 1, 2, 3, 4, 5, over by 1. So our intercept in this case would be that negative 7 if we really wanted it to be that way. We could write it as y is equal to 5x minus 7. But we would have to figure out that point. Pretty simple to figure out that point, but it's also pretty easy just to plug things into here. So we just take the 5, pop it in, done. Take one of our points, like that 2, 3, since they're both the same sign, we only have to change it to negative signs. We're good. So the reason I use the 2, 3 is they're both positive. We didn't have to switch one sign or both signs to opposites like this one. This would be a negative 1, positive 2. We just switch them both to negative. Done. We're done. So that's the reason why I chose this one, because you just need to change it one, not change both. Change only one sign in a sense. You don't have to change a negative to a positive and a positive to negative like over here. You just change both to negative, done. That's what I'm trying to say. All right. So this is another one slightly different. So we have a negative, negative, and a negative positive. All right. So again, let's start with finding our slope instead this time. 7 to negative 9, well, that's negative 16. Negative 7, negative 5, well, that's increasing slightly by positive 2. So we can write this as 2 divided by negative 16 or negative 1/8. Let's bring that negative 1/8 in. All right. Now, let's bring our points in. Notice I use the two negatives instead of the one positive, one negative, because in this case, they just both went positive. Pretty simple. So let's find negative 9. Slide it way over here. Negative 5, slide right on down. And we're going to see where we're going to intersect right over here and put that point. Now we need to do the same for the other one. So 7, find 7. Negative 7, find negative 7. And where they intersect is where we put our point. Now we just connect the two and write the equation. Done. So you see how point slope could be useful? Because this one could be that negative 6, but we would have to, again, try to figure out what happens when we put x to 0 and solve for everything. Or realize that we're decreasing by 1, going over by 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's not this negative 6 because we would have to decrease by 1 and go over by 8 again to get over here. So it's just under that. So that'll be a nasty fraction if we try to use the point slope in this one. All right. Graphing alone. So we're just going to graph this without having to do anything. Oop. There we go. Hit the wrong button. So with this, first things first is recall that we have this, the equation for slope is y is equal to negative 1 equal y minus negative 1 is equal to m times x minus x1. So we need to take the opposites of the provided values. So we take a negative 6 and we have a negative 2. That means we're going to take a positive 2. There's another way we can go about this, but we're looking for 2, negative 6. So look for 2, look for negative 6. Where they intersect is our point. Now we have that 7/3. So let's go look at that slope for a second. We see that we want to increase by 7, then increase by 3. And draw that line. Done. All right. So classwork today will be a handout, so it shouldn't be too bad. Have a nice one.